We are counting down the top 10 mega projects that forced engineers to rethink what is possible in modern construction. From next-generation power plants and ultra-fast civic hubs to tunnels that cross mountains and bridges that defy gravity, each ranked entry is a real-world feat reshaping China's energy, water, mobility, and growth systems. Expect staggering capacities, timelines that break records, and solutions to challenges that most countries would not dare to attempt. Which marvel reached number 1? Let's begin the countdown with number 10. On China's east coast, a massive new power source is taking shape. The Jinkimen nuclear power plant in Zhejiang is designed for 6 HPR-1000 reactors, each delivering 1,200 megawatts. That is a planned total of 7.2 gigawatts, enough to supply millions of homes and factories with steady, low-carbon electricity. Construction began with a milestone in December 2023. The first safety-related concrete pour for Unit 1 was completed under millimeter-level tolerances. Building multiple reactors at once means orchestrating heavy civil works, slip-forming containment domes, and threading rebar cages with no room for error. Every phase is tracked, every schedule measured against the region's need for reliable baseload power. The price tag is about 200 billion yuan, but the real cost comes later, managing nuclear waste and eventual decommissioning. For now, the site stands as a symbol of industrial precision, powering the future while raising new questions about long-term stewardship. In the heart of Guangzhou's Nansha district, a new landmark rises to meet the demands of a metropolis with over 70 million people. The Greater Bay Area Culture and Sports Center opened its doors in 2024, bringing together an 80,000-seat stadium, a world-class arena, and a sprawling aquatics complex, all under one roof. Engineers turned to modular steel construction and prefabricated roof segments, hoisting entire sections into place with cranes in a matter of days. This approach cut months from the build schedule, allowing the mega venue to go from blueprint to reality with industrial speed. Every detail, from crowd flow modeling to seamless transit connections, was designed to handle event surges and daily urban life. The price was over 10 billion yuan. While the complex stands as a symbol of modern civic ambition, the true test lies in its upkeep. Operating costs and transport overloads are already drawing scrutiny. For now, it is a showcase of scale and of what happens when architecture is scaled for an entire region. Beneath Yunnan's mountains, a colossal engineering effort is underway to solve a basic but urgent problem: water security. The Central Yunnan Water Diversion Project stretches 662 kilometers, with 558 kilometers carved through rock by tunnel boring machines, one of the largest underground conveyance systems ever attempted. Construction began in 2017, targeting drought-prone regions where water shortages threaten millions. Massive tunnel boring machines, some with diameters more than 20 meters, chew through karst formations. Teams inject grout to seal off leaks in fractured rock. The project is designed to divert 530 million cubic meters of water each year, sustaining cities and farmland that would otherwise face chronic shortages. The price tag stands near 68 billion yuan, but the scale brings its own risks. Disturbing deep aquifers could trigger unforeseen ecological shifts, and maintaining these tunnels will be a challenge for generations. For now, the project advances meter by meter, a subterranean answer to survival in a changing climate. Off the coast of Hainan, a single wind turbine now stands taller than most skyscrapers. The Mingyang Maesi 18X-20 megawatt prototype, reported by the company as the world's largest offshore turbine, reaches a hub height of 280 meters, with blades stretching 116 meters each. Installing a machine this size takes choreography on the open sea. Jack-up vessels raise the nacelle, each lift time to avoid sudden gusts, and ballasting systems are ready for typhoon swells. One of these turbines, according to company reports, can match the output of a small power station. The design pushes the limits of fatigue resistance. It is built to survive the region's notorious storms. Reality check. While Mingyang claims a 20 megawatt rating, independent verification is limited, and only a handful of prototypes are operating as of 2025. The next challenge is scaling up supply chains and port logistics before this hardware can truly reshape the energy grid. A new inland waterway is rising in Guangxi, transforming the map for southern China's trade. The Pinglu Canal stretches 134.2 kilometers from the Shijin Reservoir to the Gulf of Tonkin. It is designed to move 50 million tons of freight each year. By cutting nearly 500 kilometers off the inland to sea shipping route for Nanning, the canal promises to turn river barges into a direct line for exports. Construction began in 2022. Massive dredging moved earth and silt, and engineers installed 1,400-ton class ship locks, each designed to lift vessels across shifting terrain and tidal swings. The price tag stands at about 37 billion yuan, yet the logistics gains come with a cost. Fishing villages along the route have faced relocation, and spoil from dredging has altered local ecosystems. The project remains under construction, a practical gamble on waterborne logistics in a region where every kilometer saved translates to economic leverage. In Chongqing, a city known for its steep hills and dense skyline, a new rail hub has redefined what a passenger station can be. Chongqing East Railway Station opened in June 2025, instantly claiming the title of the world's largest by-floor area, spanning 820,000 square meters. That is enough space for 110 platforms, all designed to handle a peak flow of up to 4 million passengers per day. The station's core was built in just over 3 years, thanks to a robotized construction system that turned prefabricated modules into a kind of assembly line for infrastructure. Tile-laying robots, automated screed machines, and modular MEP units worked through summer heat and rugged terrain, allowing crews to cap major structures months ahead of schedule. Inside, concourses stretch beneath a canopy of glass and steel, engineered to channel crowds with minimal bottlenecks. Passenger flow modeling shaped every corridor and escalator, while digital controls keep the operation running at city scale. The station is now fully operational, but the reality check comes in the form of energy costs and the challenge of integrating such a vast terminal into the urban fabric. Still, for mobility and urban growth, Chongqing East stands as a new benchmark, proof that in the era of high-speed rail, even a railway station can feel like a city within a city. Across the Pearl River Delta, a new corridor now ties two powerhouse cities together. The Shenzhen-Zhongshan link stretches 24 kilometers, blending bridges, artificial islands, and a 6.7-kilometer undersea tunnel, and it is the world's widest and longest immersed tube tunnel of its kind. It opened on June 30th, 2024. This 44.7 billion yuan project was designed to move 31.5 million vehicles a year, slashing travel times from 2 hours to just 30 minutes. The engineering starts offshore. 2 artificial islands were built, one using 57 giant steel cylinders, each 28 meters in diameter. Those cylinders were driven deep into bedrock, then sealed, drained, and filled to create stable ground for the tunnel entry. In shipyard-like factories, crews fabricated 32 concrete steel tube segments, each weighing around 80,000 tons and stretching up to 165 meters long. These mammoth elements were floated out and immersed into a trench 36 meters below the surface, then joined with millimeter precision, sometimes in stormy waters and always under the clock. The tunnel's record-setting width of 55.5 meters allows for 8 highway lanes, ventilation, and emergency access. Such scale brings hidden costs. Maintaining artificial islands and submerged structures in a shifting delta will demand constant vigilance, while the ecological impact on river flows and marine life is still unfolding. For now, the link stands as a feat of marine civil engineering, an artery for trade and mobility, but one that must prove its resilience over decades. High above the karst canyons of Guizhou, a ribbon of steel now floats in the clouds. The Huajiang Grand Canyon Bridge opened on September 28, 2025, and it carries its deck a staggering 625 meters above the riverbed, nearly twice the height of the Eiffel Tower. At this altitude, the bridge faces wind forces stronger than those found on most skyscrapers. Engineers shaped the deck with aerodynamic lines and fitted it with tuned mass dampers, allowing the structure to flex and settle without swaying dangerously. The main span stretches 1,341 meters across a gorge carved by centuries of rain, anchored deep into fractured limestone. In April 2024, a sudden wind event halted cable installation, forcing teams to reinforce the anchors and adjust their schedules. That intervention averted disaster, but it revealed just how exposed the bridge is to the elements. Maintaining a structure at this height means constant inspections. Drones, climbers, and sensors all work to track stress and spot corrosion before it spreads. The bridge is not just a record breaker, it is a lifeline, connecting remote mountain towns to city economies and drawing new waves of tourism. But there is a cost. The surrounding ecosystem is fragile, and even routine maintenance risks disturbing habitats on the canyon walls. For now, Huajiang stands as proof that vertical ambition can be matched by technical invention, at least as long as nature allows it. Just southwest of Beijing, an urban experiment unfolds across 1,770 square kilometers of former farmland and wetlands. Xiong'an New Area, announced in 2017, is China's answer to the pressure cooker of the capital. A city built from scratch to absorb population and economic functions that Beijing can no longer sustain. The ambition is clear. By 2035, 5 million people are expected to call this place home, living in districts shaped by digital master plans and real-time data. Unlike most cities, Xiong'an's roads, utilities, and transit lines were mapped first in a virtual model, a digital twin that runs simulations before any concrete is poured. This platform does not just visualize traffic or rainfall, it helps planners test entire neighborhoods for energy use, emergency response, and even the flow of groundwater beneath the city. At the Linji high-speed rail station, digital twin modeling cut 65 days from the build, saving over 1 million yuan in costs and preventing clashes between buried pipelines. Such tools are now standard across the new area, from sewage tunnels to smart street grids. Reality on the ground is more complicated. Construction grids and wide boulevards stretch for miles, but the population remains thin. Officially, Xiong'an is a pressure valve, yet most arrivals so far are relocated families and government staff, some of whom left behind villages and farmland for high-rise apartments and new schools. Personal accounts describe mixed feelings. Compensation helped some set up new businesses, but others mourned the loss of ancestral land and local traditions. Uncertainty lingers over organic growth. Despite $85 billion in planned investment and a national push to move universities and tech firms, the city's future depends on whether people and companies will truly settle here, or if it will remain a showcase in search of a community. For now, Xiong'an stands as a laboratory for urban governance, where every street, canal, and park is shaped by algorithms, and the stakes are not just technical, but human. Steel rails cut a line across some of the world's harshest terrain, linking Chengdu to Lhasa over a distance of 1,629 kilometers. The Sichuan to Tibet Railway is not just long, it is a feat of endurance built at an average altitude of 3,800 meters, where the air is thin and the ground never stops moving. More than half the route, 838 kilometers, disappears into tunnels bored through granite, fractured slate, and active fault zones. The Yigong Tunnel alone stretches 42.4 kilometers, while the Sagila Mountain Tunnel pushes 37.9 kilometers under a peak that rises nearly 4,800 meters above sea level. Every meter forward means fighting forces that would shatter conventional machines. In these depths, rock stress can spike above 113 megapascals, enough to trigger sudden, violent bursts that can destroy equipment in seconds. Tunnel boring machines here are armored and pressurized, with cutter heads designed to grind through both solid stone and waterlogged karst. Crews monitor the face for warning signs of collapse, drilling stress release holes and layering 3 kinds of support to keep the mountain at bay. Even so, failures happen. In the Dormage and Dorgi tunnels, soft rock squeezed so hard that 1/4 of the original supports had to be ripped out and replaced, costing months of work and millions of yuan. High geotemperatures and thin air add another layer of risk. Inside the longest tunnels, temperatures can soar past 40 degrees Celsius, while outside, workers battle hypoxia and freezing winds. Mechanized sprayers, arch installation vehicles, and oxygen tents cut down the time teams spend in dangerous conditions, reducing exposure by up to 80% in some sections. Still, acclimatization is a daily struggle. Fatigue and altitude sickness are constant threats, and every shift is a test of human limits. Altitude matters every hour. Above ground, seismic viaducts cross valleys deeper than 2 Eiffel Towers stacked end to end. Bridge piers are fitted with seismic isolation bearings, engineered to flex and shift if the ground lurches during an earthquake. Real-time monitoring systems combine satellite, drone, and ground-based sensors to spot landslides, rockfalls, and debris flows before disaster strikes. The corridor faces more than 1,000 debris flows and hundreds of landslides, each one capable of closing the line for days or worse. Progress is measured in progress and setbacks. The Chengdu to Ya'an section opened in 2018, giving a taste of what is possible. Further west, the Lhasa to Ningqi segment continues to push through mountains and fault lines, with the most difficult middle section still under construction. Official targets put full completion around 2030, but every kilometer brings new surprises, with unexpected faults, water ingress, and shifting schedules. For the communities along the route, the stakes are enormous. The railway promises to cut travel times from days to hours, opening new channels for trade, energy, and mobility across the Tibetan Plateau. But the risks are just as real. Earthquakes, tunnel collapses, and the challenge of maintaining a lifeline in one of the world's most unstable landscapes present constant dilemmas. The Sichuan to Tibet Railway stands as the ultimate test of engineering on the edge, where every advance is hard-won, and the only certainty is that nature always gets the final say. Deep in Tibet's Yarlung Tsangpo Canyon, a reported plan could reshape Asia's energy map. China has authorized construction of the Meidog hydropower station, a 5-dam cascade projected to deliver more than 60 gigawatts of capacity and 300 billion kilowatt hours each year. The estimated price tag is $170 billion. If completed, it would dwarf every previous hydro project. But the site sits on a tectonic boundary in a region known for landslides and seismic risk. Downstream, India has raised concerns about water security and ecological impact. For now, it remains a planned project, an audacious vision with enormous stakes, and a future that is anything but certain. Across all 10 megaprojects, one pattern emerges. China treats infrastructure as a living national operating system, constantly rewriting the code to solve urgent problems at an unprecedented scale and speed. The real shock isn't just the engineering, it's the relentless drive to reshape geography, society, and even the future itself. Which project left you speechless? Drop your thoughts below.